This section we're going to talk about permutations, and the next section we have combinations. And a lot of people get confused between those two, so just remember when we're looking at the permutations, permutation is when order is matter. And combination is when order is not matter. And before we go over permutations, we wanted to know a little bit about the notations right here. We call this is factorial. What does the factorial means? So if we have n factorial, it means it multiply from n through all the way to 1. So for example, if you have 5 factorial, then this is equal to 5 times 4 times 3 times 2 times 1. Okay, and another important factorial is when your factorial is 0. So 0 factorial is equals to 1. So that's important. And the permutation. So if we know that problem is permutations, then you're going to use this formula right here. Where permutation is, this is the total numbers, total event. And this is the event that you're going to pick it out, right? Is equals to n factorial over n minus r factorial. Again, we'll be able to look at that later on example. But the first example, we wanted to make sure we understand how to use the factorial sign first. So if we're looking at this problem right here, 8 factorial over 5 factorial means you have starting from 8, multiply all the way to 1. Five factorial means starting from 5, multiplied all the way to 1. So then you can see this 5, 4, 3, 2, 1 will cancel out denominator of the same multiplications. So basically what's left over will be 8 times 7 times 6, which is going to be 336. What about this one? Well, you might say, wow, this is pretty big numbers, right? And I don't want it to multiply all that numbers. What do I do? But actually it's not, because on the numerator, you have 500 times 499 through all the way to 1, which is same as 499 factorial, right? And since you have 499 factorial on denominator, you should be able to cancel that out, where your solution will be just 500. Okay, so let's look at the example 2. So these examples are the same types of example as the section from Fundamental Counting Principle. So we should be able to use the same method, which was just picturing itself, picturing the situations and see what numbers to multiply, right? Or we can also use the formula for the permutations. So I'm going to show both ways for maybe 1 or 2 problems. So let's look at example 2. It say you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the book makes a difference to you? So here, when it's a order, make a difference. That's when you know you're going to use permutations. Right now we only have permutations, but after we go over the combinations, people seems to get confused which one to use. So I'm just going to tell you from here, right? When order matter, you're going to use the permutations. Well, let's say, so then if we know it's going to be permutations, we know that P equals 2. You have total of 7 books, and you wanted to rearrange all 7, right, by the order. So then you're going to do 7 factorial over 7 minus 7 factorial. This gives you 7 factorial over 0 factorial. We know that 0 factorial is 1. So this gives you 7 factorial, which is 50, 40 different ways. So this is using the formula, right? What about if we use the same method as the other sections that we already went over? So just picturing itself, right? So then we will say, okay, so in the bookshelf, I wanted to put 1, 2, 3, 4, 5, 6, 7 different books in an order. So let's say in this 7, so I'm going to multiply all these numbers and depends on how many options I have, right? So first book, I have 7 books, so it means you have 7 options, right? And then second book, you now have 6 options because you already placed one of the book out of 7 in the first locations. And then your next option, third book, you will have only 5 books left, and you have 4 books left, 3, 2, and 1 book. And when you're multiplying that, you end up getting exactly same number. So either way you can use in this types of problem. Let's look at example 3 this time. It's say you and 19 of your friends, so total of 20 people, right, had decided to made company, internet marketing consulting company. And once you have a company, you need to decide who's going to be CEO and who's going to be manager and who's going to be treasurer. So it looks like you're going to choose 3 officers. In how many ways can this officer be filled? So think about it if this order matter or not. And it is. Why? Because let's say we pick one person. That one person can be CEO, but that person cannot be the same person as the manager or treasurer. That option is going to be different than if that one person become a treasurer. That's going to be different choice. The same people can be chosen, but if you give the different title, that's going to be different options, right? So we'll say order is matter for this example. So if order is matter, again, we're going to use the permutations. So the permutation, we will say how many options we have. We have out of 20 people, you're picking 3 officers. So 20 factorial over 20 minus 3 factorial. So that gives you 20 factorial over 17 factorial. Again, that is same as 20 times 19 times 18 times 17 factorial will cancel out. Denominator 17 factorial. Let me just write it so you know why I don't have 17 factorial. So that will cancel out. So basically you're multiplying those 3 numbers on the numerator. And when you do that, you will end up getting 6,840. Okay, then what about if we do the other way? Just picturing ourselves, right? So we have CEO, and we have operating manager, and we have treasurer. So if we're picking the first person from the CEO, right, out of 20, my option, I have 20. Because I already picked one person to become CEO, I now have only 19 options for manager. It means I will only have 18 options left for picking a treasurer. So when you multiply that, you will end up getting the same number.